David Spieth here with one more flipped classroom math video lesson. 3 tips before we start. First, you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to catch up with notes or write down some questions. Third, you can turn on the captions and read my words on the screen. Okay, we're going to pause for just a sec and we're going to review what we've covered in the last 3 or 4 lessons in our class. And I'm just going to go over that, provide you some examples to practice, and then we're going to talk about some IB exam questions that you're going to get to work on. And this is super important because these are questions that are meant to be very similar to the kinds of questions you'll see in your IB exam in your senior year. Okay, so first topic, rounding. You had 2 ways that was requested. You were requested to round to certain decimal places, or DP, and you were requested to round to certain numbers of significant figures, or sig figs, or just simply SF. So let's just do a few problems here. In fact, I'm going to ask you to pause a video and try all of these. You've had practice, so you should be able to nail all of these. So go ahead and pause the video, and then we'll work through them. Okay, let's see how you did. 7.042 to 2 decimal places. 1, 2, that's the 4. Does the 2 over here round the 4 up? It does not. So this is going to be 7.04. That's 2 decimal places. 0.0195 to 3 decimal places. 1, 2, 3. That's the 9. So we look at the next number. That's a 5. This is going to bump the 9 up. What happens to the 9? It goes to a 0. So this one's going to be 0.020. So that is a decimal place that you would write for this one. Okay? Last one, 4.9527 to 1 decimal place. Where's that 1? That's right there. So we look to the next one. That's a 5. That means we bump the 9 up. That's going to go 0 and increase this. So 1 decimal place here will be 5.0. Okay? Okay, so now let's do the significant figures one. And remember that the default is if you don't see in an IB question any instructions about decimal points or significant figures, it's 3 sig figs. So don't forget that. Okay, 457,266 to 3 sig figs. So that would be here, 457. Does the 2 cause us to round up to 7? It does not. So this is 457,000. Okay? Now this one, to 2 significant figures. We've got 0.19278. Go to the second, that would be our significant, actually the 0 is significant. So this one's going to be 0.2. What do you think about that? Actually, I think I'm wrong. Pause the video and see if you can figure out what I did wrong. Okay, check this out. A leading 0 is never significant. Never, never. Okay? So, wrong. So we would do 0.19. That's our 2 significant figures. The 7 is going to bump the 9 up. So this is going to be 0.20. Last one. This number, 40.9793 to 2 significant figures. Here would be our second significant figure. So that 7 is going to round this one up to 41. Okay, so let's take a look at approximate versus exact measurements. I'm going to ask you a question to start this off. Can a measurement ever be exact? And you should know by now, it cannot. No matter what you do, even if you're measuring something with the most powerful electron microscope, that last digit is always an estimate. So no measurement is truly exact. The only things that are exact are things that are defined that way. So we define a foot as a certain number of centimeters, no more, no less. That's exact. Okay, so let's start looking at the first thing here is the upper and the lower bounds. So I've got 2 numbers that I want you to do the upper and the lower bound for. So go ahead and pause the video, do those. Okay, let's see what you got. All right, so the upper bound is the biggest number that still would round to this. And so this would be it's slightly less than 451.75. It can't be 75 because that would round up, but it can be 74.999999 forever. So we say the upper bound is less than 451.75. The lower bound is, we can say that's a number. It's the lowest number that would still round to this, and that's 451.65. So that would be the lower bound. All right, let's try this one here. Upper bound of 26.093. Again, biggest number that still rounds down to that. So this would be 26.0935. And similarly, and actually it's not equals, remember that's less. This would be 26.0925. So those are the upper and the lower bounds for these two numbers. Okay, so pretty straightforward, right? This got a little tricky when you got two measurements and you had to use the measurements to calculate something like area. And then you were asked to find the upper and the lower bound of the area. So the wrong way to do that, here's the problem, by the way. Actually, pause the video and see if you can do it. I'm not going to give away what the wrong way is, just do it. Okay, let's see how you did. So the mistake is to just multiply these two out and then take the upper and lower bound of the result. That does not get you the correct answer. To get the, let's do the upper bound first. To get the upper bound, we have to take the upper bound of the two numbers, multiply those together. That gets us the upper bound of the area. So this would be 2.55 times 3.55. And we'll get to that in a minute. The lower bound would be the product of the lower bounds of the sides of the rectangle. So this is 2.45 times 3.45. And this is how we get the upper and the lower bounds. Okay, so I did my calcs. I did my upper bound, I multiplied these out. This is the number my calculator showed me. No instruction here, so I round to 3 sig figs. So this number rounds to 9.05. Similarly for this, multiply these two together, this is what my calculator shows me, round to 3 sig figs, I end up with 8.45. Okay, the last thing I want to review here is what they call standard notation, which is really called scientific notation. And this is actually kind of a bad, or standard form actually is what they call it. And this is kind of bad because in mathematics we have a lot of other places where we have a standard form, we have a general form. And I'm not sure why they use this in the IB, because it's known in the science community as scientific notation. It's been known that way forever, so they should just call it scientific notation in our textbook. But they don't, so fortunately, you just have to remember that. Okay, format is some number times 10 to the n. That's what we use, and then we have two conditions. The number a has to be between 1, can be equal to 1, and it has to be less than 10. It can be really close, but can't be 10. So that's the conditions for the a. The conditions for n, for the exponent, it just has to be a member of the set integers, and that's what we use for integers, is z. So that's the integers. And remember, integers are numbers like -4, 0 is an integer, 12 is an integer. It's numbers that can be written as just single digits like that. They're not numbers that are required to be used as fractions, things like that. Okay, I've got 3 numbers for you to convert into scientific notation. Go ahead and pause the video and do that. Okay, let's see how you did. 4,567,029. Now hopefully you remembered when you were doing these that I didn't make any kind of a requirement for how you might round. So it's 3 sig figs. So what I'm going to do is I'm going to figure that out and I'm going to put it in the right decimal form first. So this is going to be 4.5. Now the 6 is going to get rounded up by that 7. So it's going to be 4.57 times 10. And now I need to find out what my n is. Here's my decimal place now. So I'm going to go 1, 2, 3, 4, 5, 6 to get there. So that's 10 to the 6th. So this is 4.57 times 10 to the 6th. Okay? Now this one, let's do the same thing. 6.2, my third digit is a 0, and that 4 is not going to round it up, so that's going to be 6.20 times 10 to the, now I'm only going 1 decimal place to the left, so that's 10 to the 1, or 10. Okay? Now this last one, we're going to go the other way. Let's take a look. What are my sig figs going to be? It's going to be 6.72, because that 8 is going to round the 1 up to a 2. And now I'm moving my decimal place to the right, so it's going to be a negative number for my times 10 to the n. And it's going to go 1, 2, 3 places, so that's -3. Okay? So that's our rounding. Okay, we're going to do one IB's test type question. And so here it is. You might see this on an exam or on a test. A student approximates pi to be 1571 over 500. So that's an approximation that works for pi. What you're being asked to do is find the percent error to 3 significant figures and in standard form. Okay? So this is the kind of question you'll see. And then in IB land, they don't say points, they say marks. That's what they do. And then as a good thing to know, generally speaking, a mark on a test should take you a minute to earn. So a 90-minute test, a test that's written to take, or the time limit is 90 minutes, that test should add up to approximately 90 marks. So that's kind of a rule of thumb for that. Okay, so obviously a word problem with percent error. So I'm going to put up my formula for that first, but actually what you're going to do is you're going to pause the video right now and see if you can do this. And there's 2 parts, percent error to 3 sig figs and in standard form. So see what you can do. Okay, I'm going to put that formula up here, and that was percent error, let's write percent error, is the absolute value of the approximate measurement, the value of the approximate, and the value of the exact over the value of the exact, close my absolute values, times 100%. Okay, so that's my percent error. So let's do a plug-in. We've got absolute value of 1571 over 500 minus pi over pi. Close that times 100%. So let's get out the handy dandy calculator and do that. Okay, plug in the values, multiplying by 100%. What I get is 0.012966239%. Forget our units. So, are we done? If you said no, you're correct. The percent error to 3 sig figs. So we've got to round this. Here's our 1, 2, 3 sig figs. So that's going to be 0.012. Oh, wrote that too soon. The 6 is going to round the 9 up to a 0, which is going to round the 2 up to a 3. So it's 0.0130%. Are we done? Do we have all the marks? No, we're not done. We also had to do it in standard form. So we're going to take this and we're going to go, okay, there's where my decimal place is going to be. My 3 sig figs are right there. So it's going to be 1.30 times 10 to the something. And now I'm going to move my decimal to get there. 1, 2. That's going to the right, so that's -2. So there, percent. So there's the percent error in standard notation, or standard form as they like to call it. Now that you've watched the video, take a minute to jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch portions of the video that were a little bit challenging the first time. If you enjoyed the video, please click like. And if you'd like to help me grow my YouTube channel, please click subscribe.